Welcome to Flip Chemistry. Today we're going to be talking about electron configurations and what they mean. Most students in my course, you've probably received a chart on the Aufbau principle and the order of filling in orbitals. If you haven't, what I would reference is a sheet that says the diagonal rule of filling in atomic orbitals, which is going to help you out today. You're going to need a notebook, obviously, today, and a periodic table to help you out today. So, this concept of configurations. So, what a configuration is, it tells a chemist and a physicist the likelihood or the most probable place where an electron resides at any given time. So, just to read off the slides here, an electron configuration is the distribution of electrons among several orbitals within an atom. In other words, an orbital is a space. It's a three-dimensional space where an electron probably resides, and it's based on its energy content. Electron configurations follow what's called the Aufbau rule, and Aufbau in German means to build up. So the analogy that I use in my class is when a contractor wants to build a home, he or she starts from the basement and they work their way up, right? A contractor will dig the foundation, they will pour the foundation, they will then frame the house, and so on and so forth, and they will build their way up. Orbitals fill in at the lowest level and build their way up. And there's an ordered sequence here, right, to the Aufbau principle. That's a fun word to say, Aufbau, right? So some examples. So here's an example of a configuration. 1s2, 2s2, 2p6, 3s1. Now, what's in blue here, the 1, the 2s, and the 3, this is the principal quantum number. It's the shell number outside the nucleus where electrons reside. Underlined in green here, there's S's and there's P's. These are subshells within the shell. For example, 2, S2, second shell 2, S is a subshell within the second level, and these exponents are the number of electrons within that subshell. So think of it as a book with various chapters within it. And within those chapters, there's sentences. So this would be your book, chapter 1, sentence 1, and so on. It's almost like a drop-down menu, right, on a computer screen. For example, the second shell has 2 plus 6 is 8 electrons. And of those 8 electrons, 6 of the electrons are in the P subshell, which is in the second shell. Looking at this, it ends in 3s1, the configuration does. Which element is this? How am I going to know? If I count the exponents here, 2, 4, and 6 is 10 plus 1, what's the 11th element on there? It's going to be sodium, right? And if you look on your periodic table, sodium is in the third horizontal row, and its group, including hydrogen and so on, all end in S1. So this is the sodium atom, right? Sodium symbol is Na from natrium, and there's 2 electrons, 1s1, 1s2, in the 1s subshell. And there's 2 electrons in the 2s, and there's 6 electrons in the 2p's. For a total of 8 electrons in the second shell. And then lastly, we have this 1 electron in the 3s1 subshell. And that's the Bohr model of the sodium atom. Right? That's how our configurations relate to how we fill in the electrons within the Bohr model. So what I'd like you to do at this time is you have 4 examples here, A, B, C, and D. And I'd like you to try to write the configurations for hydrogen, neon, sulfur, and calcium. Pause the tape, and my next slide, I'm going to show you the answers. Okay, welcome back. So let's take a look at what we have here. So hydrogen, it's the smallest element. Its first shell gets filled in. The first shell has an S subshell with only 1 electron. That's the configuration for hydrogen. If we look at neon, neon is the 10th element. So the first shell has a subshell S that has 2 electrons that fill the 1s. Then we start venturing to the second shell that has an S subshell that has 2 electrons. But neon also has in the second shell p orbitals that have a total combined electron count of 6. 2, 4, 10 is the configuration for neon. And we keep on building up towards larger atoms. Sulfur is number 16. Notice my sequence is always 1s, then 2s, then 2p. Oops. 2s2, 2p6, 3s2, 3p4. That third shell now has a p subshell. And finally, calcium, the first shell is full with 2 electrons. The second shell has the S and P subshells full. Its third, or 3s2 subshell is full. 3p6, that's 18, and we have 2 more to get to 20 calcium, and that ends in 4s2.